So there is a variation in raw material delivery time, and managers want to take advantage of procuring using the economic order quantity, the EOQ that we talked about before. They would like to use this. This gives them an optimized quantity in terms of the cost of the product, the demand, and the holding cost. Since we know that it is going to be equal to 2 times the demand times the cost over the holding cost. So the EOQ basically gives you a good way of finding the quantity also. So they want to take an advantage of this to make their inventory as efficient as possible and control it. There are also domain-specific reasons. This is domain-specific in terms of the company or the industry they are with. Companies receiving parts from far-off lands like Korea, China, India, and Japan or Thailand, they have various reasons to anticipate their questionable transit problems and their strategy also. And this also has problems due to government tariffs that we are looking at right now. There is also another anticipation, and there is also hesitation, and you're wondering whether this is the right thing to do, those kind of things as well. That is the purpose of inventory management, to understand and make sure that you deal all these factors. Let's talk about some costs. Holding costs, they're also called carrying costs. This is the cost for storing, handling. It includes insurance, any problems of pilferage, breakage, obsolescence, depreciation of value, taxes, and also the opportunity cost of capital. All these are holding cost. So when I say H, the holding cost, it means all these costs. Setup or production change costs. These are costs for obtaining necessary materials, arranging equipment setups, filling out the required papers, and so on. For instance, if you want to change tire for your car, you're going to set up now. You need to park the car, you need to jack up the car using the jack that is provided to you. You need to make sure that the car is not tilted and nobody is inside the car. All those things are setup time. And whenever we talk about time, it costs, basically. Ordering costs are costs of placing an order and maintaining the order. For instance, when you're doing a purchase order system, you're involving a lot of people. You're including the person who initiates a project, the product, the manager of the initiated team. Then you have the project manager, then you have the purchase department, you have the various VPs and CEOs and everybody who needs to sign them. These are all costs, time. So there are some ordering, and also you're going to use a computer system, you're going to use billing, you need to have the right way of getting the money, right way of sending the product. All these are ordering costs. Shortage costs are basically the stock out costs, which we considered in chapter 8. So the shortage costs are if you do not have enough inventory, then you're going to pay for it somehow. You need to buy it from outside, or you need to transfer it from another plant, or you simply have to take the loss. These are all costs of stock out as a stock out cost. So these are the different costs that we will be considering when we talk about inventory. There are 2 types of demand. One is independent demand, another one is dependent demand. Independent demand, for instance, Let's say you have a workstation, a lathe. It produces many parts. But some of these parts are not related to each other, but then they meet external departments as well. That is an independent demand. A dependent demand basically is the need of one item, the direct result for the need of some other item. For instance, if I'm making the cup handles, and then the cup handles is very important for the cup so that you can put a handle on it. So that is the dependent demand. We have a design matrix here of inventory control system. So let's say we have an independent and a dependent demand. We have transaction cost high and low, and we had risk, which is obsolete inventory, which is high and low. Depending on the demand or the obsolete inventory or the transaction cost, we can say that the manual two-bin way of doing control systems is very independent, and the rate-based synchronous planning is dependent. And also it has got low transaction costs. Let's look at the materials requirement planning that we did in chapter 10 or 9. The materials requirement planning is sort of dependent. We know that because we remember we did the tree, A, B, C, and all that. Remember the tree that we did? So that is dependent. Each part is dependent to another part. The transaction cost is pretty low simply because we are putting out a good purchasing plan. And also, since we are using the economic order quantity, or we are using a lot for lot, or a particular quantity, we can say that the obsolete inventory risk is going to be low. Not very low, but low. So this is one of the probably a good way of designing the inventory control system. We're going to be looking at two models. One is a single period inventory model. Another one is a multi-period inventory model. A single period inventory model has got a one-time purchasing decision. Like, I want to buy gallons of milk for this week. That is a one-time purchase decision. Or a vendor, a shopkeeper, is buying t-shirts at a football game that one time. It seeks to balance the cost of inventory, overstock and understock. It's just going to buy the right amount. Multi-period inventory models have two different models. One is a fixed order quantity models, where there is a reorder point, and when the reorder point comes, that is going to act as a trigger to buy some more of the stock. A fixed time period model is every week on a Wednesday evening, I'm going to place an order for this particular product. The quantity might differ, but I'm going to place an order so 1 week I'll buy 20 of this product, another week I buy 200 of this product, but I'm going to buy it clockwise, right on time, Tuesday evening. So that is a multi-period inventory model. Okay, so we're going to be doing these three models in this class. Let's consider the single period inventory model. So the first question that I'm going to pose is, while you were a kid, probably you were selling newspapers. And at that time, did you know how many newspapers you need so that you sell all the newspapers? You don't want too little newspapers or too many newspapers. Too many is going to be a waste because you cannot sell them. Too little means is an opportunity cost lost. Okay, so let's take this. You can look at it from the book, which is page 356, 357. Assume that a mean is 90 and the standard deviation is 10. The mean is 90, the standard deviation is 10. Assume we want 80% chance of not running out of newspapers. So we need an 80% probability of not running out of newspapers. We are going to also assume that the probability distribution is normal, which is this is the normal curve. Stocking 90 papers, the mean, yields a 50% chance of stocking out. So basically what we are saying is, if I stock 90 papers to sell, I have a 50-50 chance of not meeting my demand. Okay? So this is a simple one to do. So you're taking the mean, you're taking the deviation, and you're using when we are not going to run out of stock. There is an 80% chance of not running out. That's what we want. So when we say 80% chance of not running out, this is an 80% probability, which is 0.8. So we go to Appendix E. The Appendix E is going to give you a table. In that table, under G of C, which is the probability, you're going to look at 0.08 and you're going to say the Z is 85, 0.85. So Z gives you the standard deviations. So we can say that we need approximately 0.85 standard deviation of extra papers to be 80% sure of not stocking out. Okay, so if you want to know what is the standard deviation of extra papers that we're not sure of not stocking out, we are going to say it is 85%. And you can use, to get the same 85%, you can use Excel. You have to use the function norm.s.inv and then you put the number that gives you the actual z score. So let's also look at another equation. What is the probability of a given newspaper that is not the given newspaper that will be sold? So that you need to consider the cost, because you're looking at profit. So the cost per unit of demand overestimated is CO, and the cost per unit of demand underestimated is CU. These will be given to you, and so you can find the probability. So basically what it tells you here is we should increase the size of the order so long as the probability of selling the quantity ordered is less than or equal to the ratio, this ratio. So we need to increase the size of the order so long as the probability of selling the quantity is less than this CU over CO plus CU, which are the cost of demand overestimated and underestimated. So let's do some problems with that. Let's apply this single period model for overbooking of airline flights. Usually this is a problem.